Okay, let's take a look at this question. It's a specimen paper question. A bit unusual. Let's see in what ways is it unusual. First, we may see this before. A cross B equals to C cross A. We may discuss how we want to tackle this. But more unusual is this fact that they want us to find a linear relationship between A, B, and C. Some of us may wonder what is a linear relationship. My suggestion is when you see unfamiliar question like this, don't leave blank yet. We start off with what we are given and have a rough idea how we're going to proceed. Rough idea. Of course, you've got completely no idea, of course, you're going to leave blank. But if you have a rough idea how to proceed, then you proceed first, then decide how you're going to deal with the linear relationship later. So if you are given A cross B equals C cross A, we start off by writing this A cross B equals to C cross A, and the usual way we would want to do it is to minus C cross A on both sides, and you get this. Now I want to stress that this is a zero vector. Zero vector like that. Not zero. Why? Because this is a vector. A cross B is a vector, not scalar. C cross A is a vector. You minus the 2, you get zero vector. Essentially, it's this one. Not zero. Okay, a zero vector is like that with x, y, z component 0. So, we get that. Then what do we usually do? We will try and factorize. You call them inverted comma factorize. But before we try and do that, we must observe that, look, this is C cross A. C cross A and A cross C are different. So I would not do this first. I would first do this A cross B plus A cross C. Reason, we say since A cross C equals to negative C cross A. We justify. Everything we try to be nice and we justify why we do certain things. Alright? Then, only then we can, what you usually say, factorize. I wouldn't say factorize, I would just say this is the reverse of the distributive property of cross product over addition. Okay, now, sorry. Then you have a vector, cross a vector equals to 0 vector. And there are only 3 possibilities. One, this vector is 0. 2, this vector is 0. All these 2 are parallel. Now, A is a non-zero vector. So we justify that. Alright, it's given the question. Next, look here, B is not equals to minus C. That means B plus C not equals to 0. So it's also given that B plus C not equals to 0. Then you are only left one conclusion, correct? Therefore, A is parallel to B plus C. So at this point, we try and look. We can stop here. If you want, you really got no clue what linear relationship means. If you no clue what linear relationship means, we could have stopped here. Alright, you say, okay, I rewrite here, A parallel to B plus C. You could have stopped here and say, okay, I'm stuck, I don't know. But let's think. Relationship means we need to try and find equal sign. What is a linear relationship? X equals to 3 plus 4y. This is a linear relationship. Yes? Must have equal sign. No square, no nothing. X equals to y squared is not a linear relationship. Right? So, we must attempt to have an equal sign. Then we go, okay, then equal. This is as much as we can do. Therefore, this is a linear relationship. Done. Yep. Okay? Now, let's take a look at part B, sorry. Again, another unusual question. Yes. There's this word variable vector. Then you scratch your head. Correct? Variable vector, satisfy this one. This may not be as unusual, but Yeah, it's fine. Then you find the set of values. The question again a bit unusual. You want to find set of values of set of vectors and describe this set geometrically. Now, my suggestion is again similar to approach. The approach is similar to part A. We try and work with something that we can be a little bit more familiar with. Work with this one. We are given that V cross 1, 0, minus 3 equals to 0, 2, 0. Then ultimately you want to find V equals to what? Then the last thing you want to do, the wrong thing you want to do is, okay, I divide both sides by 1, 0, minus 3. Divide. There's no such thing as division, sorry. In vectors, you can only multiply, dot product, cross product. There's no dot division, cross division, sorry. So how do we proceed? There's no other way unless you let V be equals to X, Y, Z. That's the only way we can do it. Let V equals to X, Y, Z. Because you can't do division, there's only way you let it X, Y, Z. How will we then eventually solve the set of values and then geometrically worry about it later? Okay, we proceed. I don't think it's difficult for all of us to proceed. You say X, Y, Z, cross. We can all do cross product. Yeah, we do cross product. You realize that this is minus 3y. This is 3x plus z. This is a minus y. Now equating, what do we get? Equating, we will get a, look at the first line and the third line, we will immediately get y equals to 0. Therefore, and you look at second line, you get 3x plus z equals to 2. Right? So how do we interpret this then? Okay, let's go up. Maybe you can stop here. Maybe up. I can say if you had stopped here, out of 5 marks you probably get 2. Not too bad. Not the best thing in the world, but not the worst. So we stop here and say, okay, how do we then find the set of values, set of vectors, I beg your pardon, V? We now then, okay, therefore, can we then write this? Therefore, can we say V equals to X, Y, sorry, don't need to use Y already because Y is 0. 0, Z, correct? Such that, I mean, it will be more precise, it will do this. R cube means there are 3 values here, alright? Such that 3x plus z equals to 2. Okay, when we say set of values and we enclose it set of values. I know you're not familiar with this notation. I mean, I don't think Cambridge will be very, very particular. I mean, if you really just write this x0, z, and 3z plus z equals to 2, I don't think they will really fault you. I mean, this one is really something that you're not familiar with. Okay? Now, I'm going to erase this. I think this makes sense because all we are saying is now x, the y component of vector v must always be 0, and z, x and z component must satisfy this equation. That's that. Actually, as we finished the first part, we had actually found the set of values v. Now we just want to describe the set geometrically. Now think, what does this remind you of? If you were to rewrite it like that, that means what we are going to rewrite it is this, That means we have x 0. If I make z the subject, it is 2 minus 3x. Like that, That means if I write like that, what kind of equation do you think it is? Do you think it's the equation of a line? Yes, you can sub many values of x. It's equation of a line. So then, in order to answer the question, what is it geometrically, I can rewrite this as, therefore, v equals to x0, 2 minus 3x, where x. Yes? Okay, let's be clear. I would write it as 0, 0, 2 plus lambda 1, 0, minus 3. Then it looks very familiar, right? Then it looks very familiar that this is actually an equation of a line. Yes, equation of a line. So, therefore, the set is a line passing through, 0, 0, 2 and parallel to 1, 0, minus 3. Done. So this part I understand is a bit strange to you, but you look at it, then it makes sense. That's all.